Hello, welcome to this tutorial where I'm going to show you how to make a laser using a line renderer in Unity 3D. And you could use this to, like I've done, force push objects around and things like that. What we're also doing is using the mouse position on the screen to guide where the laser is firing. Okay, so, and thank you to Josip again for asking this question, how do you make a laser? Hopefully this will answer your question with a line renderer. So all I've got in my scene is a directional light, the terrain, some kind of vehicle or character. Mine's a cube that is transparent, just so you can see the scene a little bit better. And it's got a main camera parented to the back of it. As long as you've got a main camera that is tagged with main camera, that should be the default in Unity. I've got a point light that I'm just using for the laser's like effect when it hits a collider. I'll just turn that off. And then I've got a spawner that made those little game objects that I can push around in. So that's optional. So all you would probably need is a terrain and a vehicle and your main camera. So the stuff that will be in your scene by default, really. So let's get going. So to make a laser script, we'll create a C# script in our assets folder, and I'm going to call that ray gun, like a 1950s sci-fi thing, a ray gun. Before I forget, let's add that script to the vehicle or character or game object that you want to carry the ray gun. There we go. So if I click on my drone now, I've got, yes, that laser script enabled, which should be disabled. That's my laser that was working that you saw at the beginning there, but I've got my ray gun. Lovely. At the moment, if we go into the scene, we should still be able to move around, and we should have lots of little blocks spawning around, but now when I press the mouse, I'm getting nothing happening, because my ray gun is empty, of course. So we'll double click on that script, and we'll delete the traditional delete of the comments above start and update, and we'll write our script. We won't need those. We'll write our script to create a ray gun. So first we need a line renderer. So you could attach that in the editor, but sometimes it's fun to do things in the code. So we need a private line renderer. We'll call that our beam, like a laser beam, and then we'll make it in the start function. So we'll say beam equals this game object dot add component. What's the time? 5 past midday. Line renderer. Right, so we've got our line renderer, and we're storing that in the beam line renderer object. What we could do is set the start width, and around 0.2 is pretty good, and we could also do the end width as well. So you can fiddle around with those widths to change the look of your laser. Right, let's see if we can stick that laser to the front of our vehicle. So in update, we want to check laser, or you could call that fire laser or whatever else. So I'm going to make our function down here, void check laser, there we go. So in here we're going to determine where our laser is firing from and where to, and render it. What you could also do is we could ask this question: if input mouse button, no, input, what is it, get mouse, input dot get mouse button 0, that means we'll only go and check the laser if we're holding down our left mouse button. Okay, so in check laser, what we want to finally do is draw the laser. And one way to not draw the laser, actually, we could say beam.enabled equals false. So straight away, if we're holding down the left mouse button, then we're going to check the laser and draw the laser. If we're not holding it down, then we're disabling the laser. So the first thing we want to do in check laser, or maybe at the end, I've literally just pasted it from that line to this line. Right at the end, if everything's gone okay, then we can say, okay, switch on the laser, and the laser should appear. There we go. Draw the laser. What we want to do before that then is decide where the start position is. So our beams.setPosition, so we want to set the first position in the array. Essentially, a line renderer can have as many points as you want. So those points will be 3D coordinates in 3D space, so vector 3 objects. And you can have as many as you like. I like doing that gesture. We're just going to have two, the start of the laser and the end of the laser. So that's the start position will be indexed at 0, like I'm determining here, and the end point will be indexed 1. Easy. So our start position wants to be this transform. So that means whatever this script is attached to, that transform. So in other words, our vehicle is this transform. And we want its position plus, now if we just go into our scene, here he is. So the Z direction, this blue arrow is pointing forwards. Our transform position is right in the middle of that cube at the moment. So we want to go from the middle to the outside edge. We want to start our laser about there. So that's going to be the 0, 0, 0 position plus forward, so that's the z-axis, times not the whole scale, so not the z scale here by 1, but by 0.5. And that will be the skin, the forward skin edge of our object, of our vehicle. So at the moment we've got the 0, 0, 0, the middle position, so that wants to be plus this transforms forward, so whichever way it's pointing forward, the z position, times 0.5f. There we go. So we've set the start position and the end position. So just for now, let's just see if we can get a laser pointing out 3 meters ahead, something like that. So beam dot set position, and I say 3 meters, I mean 3 units, whatever it is. It's going to be the origin. I'm going to pretend I've got a variable already, plus this transforms position for this. So similar kind of logic, going in towards the direction that the vehicle is facing, and this time, well, I'll put 9 meters in. I said 3 meters. Let's go 9. Right, so we haven't got an origin at the moment, so I'm going to say origin equals that, the set position. Will that work? I don't know if setting a position will actually return anything. It probably won't. So up here we need a vector 3 origin. You know what, while I'm up here, we're probably going to need an end point and eventually a mouse position as well. So we're going to create all those 3D points up here now, so that we're not creating and destroying 3D objects in the update loop, in this checked laser bit, which will be more costly. So we can't do that. So origin is going to equal our beam's get position, and we're just going to get the first index, 0. So we've just set that position there, and now we're going to get it in the next line and store that in origin, just so that when I'm dealing with these calculations, I can put in origin instead of having to put the whole thing in or get the position. Okay. So, review. We've set the start position. we've stored that in origin, and now we're setting the end position 3 meters ahead. So what might be nicer actually, because we've got our endpoint, we could say endpoint equals origin plus that times 9 meters, 9 units. And then we could say endpoint in there. Okay, that looks a lot nicer. So set end point of laser and draw the laser. And here we are finding the origin and endpoint of laser. So kind of thinking of things more methodically. First we're finding those positions, and at the end we're setting those points. You know, I'm not quite doing it that, am I? We're setting those points and then drawing them. So in fact, we should take this out and put origin, and origin is going to be that, and we can take that out. Okay, so I'm kind of just refactoring, they call this, refactoring your code. So the origin is the vehicle's position plus 0.5. Okay. Oh, by the way, what would be better is also times the actual scale of your object. So you might have a massive thing, you might have a model that's kind of different. So if we just put in this transform lossy scale, so that's like the world scale, and we just want the Z dimension. Okay, so that's not really changed anything for me. That number is going to be 1 for me, because my scale happens to be 1. It just means if I rescale my object, then that number will now be 2.98. So 2.98 times half of 2.98. So it will still end up exactly at the front of my vehicle where I want it. So that's a bit of better practice. Is that correct? No, there we go. Missing off some semicolons, sorry. Can I brighten my screen? No, it's full brightness. Okay, right. I'll just put that back to 1. Or maybe I'll put it to 2. Just so we test this out. I think I've saved my script, so what should happen now? We should have, yeah, a 9-unit long laser sticking out the front of our vehicle when I press, yes, the mouse button. There we go. So we've got a laser switching on and off, which is pretty cool. Okay, I just wonder, let me just play around. We could take off this enabled thing. Oh no, we could leave that there. Maybe. Just wondering, if we never switch off the laser, that would mean it's going to be drawn from the last place you were holding down the button. So it might leave like a Kylo Ren kind of frozen laser in the world. Yeah, oh, that's kind of cool. Got force powers. So if you hold down the button, then it travels with your vehicle, because our start position is being recalculated. But if you let go, you can kind of leave the laser beam there. Anyway, so it's fun to discover these like little buggy kind of things as you go along. Sometimes you might discover a mechanic that's useful. I don't know, I've got a little idea, I might be able to use that. Right, so what we want to do now is determine the end position of our laser according to where our mouse is. So for that, we're going to need a camera. Right. So let's build a variable to store that. Camera, we'll call you cam. And in the start position, we've grabbed our laser. In fact, we've created our laser, our line renderer. What we want to do now is grab the main camera. So that's very easy to do. We can say cam equals camera. We can use one of the functions built in here. Just write main. So what that does is go and look for the object, the camera, tagged with main camera. So if I find my camera, which I think I've already said is parented to my drone, if I go and find that camera, you'll notice it's got the tag main camera. That's really important. It allows this function to happen. So that will go and find whatever's tagged with main camera and return it here. So we've got our main camera. That means when we're checking our laser, now we want to kind of adjust this. We don't want to say our endpoint is just 9 meters ahead. We want to say our endpoint equals the mouse position. Let's just go and see what happens there. This might be something that you've tried and it doesn't work. Let's just see if it works for us. Okay, we can fly around as normal. So I've got my mouse up there and I'm clicking the line renderer. So something's happening at least. It's kind of like reversed. Bizarre. So our endpoint is moving relative to the mouse, but it's certainly not landing where our mouse is in a 3D scene. So we've got to go from this raw position to a screen position. So first thing we'll do is store the mouse position in its own variable. I think I already made that, didn't I? Yeah, mouse position. I've already made that. So we can say mouse pos equals input mouse position. And we'll delete that at the moment. Okay, so we want to translate that to the screen position. So we want to say mouse position equals you know what, we'll do this in one step. Let's say mouse position equals camera. We've got hold of our camera, and we can say screen to world point. So that translate from our raw input x and y of the mouse and transform that according to the projection into 3D space, which is lovely. And we want to go from the mouse position. There we go. And let's just try running this. You might be quite hopeful at this point. Will that have done things for us? I'm just looking at my chihuahua. She's gone to sleep, haven't you, Doctor? Yes. Loves the sunshine. Okay, something's happening. We're kind of closer to the mouse now. It looks like it's going to 0, 0, 0 basically. So it's still not working, but something different is happening at least. So there's some hope in there, but there'll still be some frustration. So one thing you may have noticed is that mouse position will only hand us back an x and an x and a y position on 2 dimensions, and we want to project into our screen. And so we can think of this in terms of the range of our laser. If we gave it something like 300 units, then we might be getting somewhere. Also, what I've just noticed is that, of course, I've not set the endpoint to the mouse position. So let's just do that first. Endpoint equals mouse position. That explains, I was just thinking we're getting 0, 0, 0. I had no idea why, because endpoint is empty. It's 0, 0, 0. So I'm curious to see now, what are we getting? aha, it's kind of shooting us in the face. So it's maybe trying to follow the mouse position, but it's got no Z component. So let's just say mouse position Z equals 300 into the scene. What happens then when we play? Okay, then it's shooting 300 meters on the z-axis far away. So the trick seems to be we need to adjust this before we translate. We use this function to translate. So let's just refactor it. Right, let's refactor this. So delete everything. So first we're going to say mouse position equals camera screen to world point input. No. Mouse position equals input mouse position. Then we'll change mouse pos z equals 300f. Then we'll translate all of that into a world point in 3D space. So equals camera dot screen to world point mouse pos. There we go. I think I've just opened up Siri accidentally. Remove from dock. Oh, I've only got about 2 swigs of my tea left. Okay. Now we're cooking. So I've just gone through all of those steps and kind of like debugging, because it might be the kind of thing that you've gone through. Whoever's watching this, thank you for watching, by the way. Just to show you that sometimes just rearranging the order that you do things in is very important, obviously. So what's happening here is exactly what we want. The end of the laser is finding where our mouse is ending up in 3D space. One thing you may have noticed, however, is that when we fire, we can fire through objects, which may be what you want. In my case, it's not what I want. I want this to act like an actual laser, where it's hitting the collider of the terrain. It wants to stop there, so that's the end point of it. Okay, so to do that, our kind of like final stage, we need to cast a ray. So we're going to use the physics engine to cast like a ray, which is essentially a laser, an invisible one in this case, from the origin position towards our end point, which we've already found. However, if it hits a collider, an object's collider, then it stops there, and whatever hit point that is, that will be the new end point of our laser. That's what we'll do. So then we can't go through objects. So first we want a new hit thing. So what is that called? Raycast hit. Raycast hit. We'll call that hit. So in there we're going to store whatever collider or the point. You know what? It's going to return lots of information about where we've hit. All we're interested in is the point in 3D space, a vector 3. So then we ask the physics engine, could I have a new Raycast, please? So first we want the start point of our ray, which we've already worked out. We want to go from the origin. Then we want a direction. So I haven't got that yet. We'll call that dir for direction. Then we want to store the the hit information in hit, so we write out hit, and then we want to say how long we want our raycast to be. So I've set up here that we're kind of projecting 300 units into the scene, so I'll put 300F in there as well. Okay, so what this does, actually jumping ahead of the ray gun there, what we want to do is encapsulate this in an if loop, an if statement. We want to say if this returns true, then do this. Okay, so you'll often see raycasts within an if statement. So if this returns true, it means that it's hit something, because we're outputting into hit. Right. Oh yes, we need a direction. So we need a vector3 direction equals, so to get the direction of our laser beam, we want to have the endpoint minus the origin. You see my other hand, sorry. The endpoint minus the origin will give us this direction, and then we don't want like the whole magnitude, we just want it normalized. That means converting the vector to a unit of 1. So it just gives us the information of where it's pointing. So we want endpoint minus origin, and then we want direction normalize. As easy as that. So we've got the direction of our laser. So let's just record that in here. In case I put this code up on GitHub, it might be useful to know what it's doing. Find direction of beam. What am I doing here? I'm finding mouse pos in 3D space. Delete that. Finding origin endpoint of laser, lovely. Find direction of beam. Right, and then we're asking the question, are we hitting any colliders? If we do hit a collider, if yes, then set endpoint to hit point. So we're going to say endpoint equals hit.point. And what hit.point returns is that it's a wonderful little function there. It just returns the 3D point where we hit the collider. Very, very useful. Okay, so that should be it. Can that be it? What time did I start? So this is just under half an hour, so I've got like 5 minutes. If this bit works, oh, it has, it's already worked, lovely. So we can guide our laser around, and as long as there's nothing in the way, it will hit precisely where you put your mouse. If there is like a hill in the way, then it stops according to that line of sight. That is wonderful. So I've just said line of sight. You might use this for actual line of sight mechanics. There we go. What I really should do is just show you how to add a force. So what we could do in there, we could say is it hit dot transform dot, oh I know, we need to ask the question, if our hit transform dot get component rigid body does not equal null. So there we're saying, has the object that we've hit got a rigid body? So our terrain won't have a rigid body, but those little cubes that have spawned into the scene, they have got a rigid body, which is very important. That means if something's got a rigid body, it interacts with the physics system of Unity. It's not just kinematic. So has this hit object got a rigid body? If so, then hit.transform. Oh, we just want to get hold of that rigid body again. And then add force. And we want to say the direction that we want to add that force in. We've already found the direction of our laser, so it makes sense to travel along that direction as well. And then force mode, I think impulse works okay. There we go. So if we've hit an object and it's got a rigid body, then we can add a force to that object using the direction that we've hit it. Using impulse should be able to push it enough so that uses the mass of the object relative to the force. Let's just see if that works. Yes, there we go. So I'm hitting those objects. Because they've got rigid bodies, we can push them around. Right, that'll do for this tutorial. Ask any questions in the comments and I'll try and answer them. Thank you very much for watching. Goodbye. And I've just stopped the thing, not the video.